Good afternoon, everybody. This is Krishna Chaitanya, Assistant Professor, Department of Computer Science Engineering, GRIT, Hyderabad. Today I am going to discuss regarding the overview of C++ overloading. Overloading occurs when the same operator or function name is used with different signatures. It should be noted that both the operators and functions can be overloaded. Overloading can be applied for operators also. The most important aspect is different definitions must be distinguished by their signatures. The signature is something which consists of the name of the function and the list of the parameters. Signature is the operator or function name and the ordered list of its argument types. For example, you can see it on this slide. We have taken two functions, add with parameter int and long, and the second function with the same name add, whereas the order here is different. The first parameter is long and the second parameter is int. Now these two functions have different signatures. So this part is called as signature, add int comma long. This is one signature of one function. In the same way, add constant base, and this is the address parameter what we are sending, as well as add a constant type of parameter derived, have different signatures even if derived is a base class. That we should understand. So what happens when multiple function names are there? The most specific match is used to select which one to call. Let's go for the next slide. Here we can see the example. We have taken one class A, public, where we have taken a function by name add. Now we have two signatures available here. Int add with two parameters I and j, both are of type integer, whereas the second function long add with both parameters long m and long n. Now there are a couple of comments given to make it more clear that people may think the function signatures with different return types may also be considered as function overloading, but it does not take place so. So that's what it is given. It would be ambiguous with above if I have long add with int m and int n. If you compare these two things, int add int I int j as well as long add int m int n. Now in these two cases the difference is only in the return type, but this becomes an ambiguous one. It is not function overloading. So here, whereas we have long m and long n, int I and int j. So here add is the same name we are using, so this is function overloading. When we give two parameters, int a is equal to 7 and int b is equal to 8 initial values, and send it to this calling statement add a comma b, the resolution of which function is to be overloaded, which function is to be executed, is taken place based on the parameters that we have sent, because these are two integer values. The first function int add int I comma int j gets called. So calls to the overloaded functions and operators are resolved by finding all possible matches based on the passed arguments. It may involve type promotion also, may involve instantiating the templates. Finding the best match among those possible matches is a thing what happens, and signature does not include the return type. This is most important, which might not help even if it did, that is calls may ignore the result. So overloading cannot be resolved by return type alone. Compiler generates an error if the call cannot be resolved. So insisting on the same point, function with the same signature and same name but different return types are not allowed in C++. You can have different return types, but only if the signature also differs. So float, square, float f. This is another example what we are seeing. Double, square, double d. So these two parameters are different. So return types are also different. No, it's a pure function overloading example. Moving on to the next slide. The summary of what we have discussed. Generally, the use virtual overriding when you want to substitute different subtypes polymorphically. So this is a kind of polymorphism what we are looking at here. So move in the derived and base classes, both types you can be having. This is overriding concept. Overloading and overriding are a bit different. Once again, tips on overloading. Use virtual overriding when you want to substitute different subtypes polymorphically. Use overloading when you want to provide related interfaces to similar abstractions, as shown in the example. use different names when abstractions differ. So before we conclude, let's try to once look on this look at this particular overloading versus overriding. Overriding a base class member function is similar to overloading a function or operator, but for overloading, definitions are distinguished by their scopes rather than by their signatures. So which class does the function belongs to? Based on that, overriding happens. C++ can distinguish method definitions according to either static or dynamic type. So it may be a dynamic type of binding, or it may be a static type of binding. Depends on whether a method is virtual or not. Depends on whether called via a reference or pointer versus directly on an object. It also depends on whether the call states the scope exactly. As shown in this example, the BAZ function, bash function exactly belongs to FOO. This is scope resolution operator what we are using here. Thank you.